And welcome back to another live stream. We're happy to join you today from all over the world here. Excited to get going. My name is Chris Alexiak. I'm a product research engineer here at NVIDIA, and I'm joined by
Chintan Patel, product manager for NVIDIA Nemotron.
Awesome. Okay. And before we get into the kind of swing of things, we're going to go over a few ways that you can stay in touch with the community and keep things rolling. So first things first, of course, if you want to use our models, try them out in your use case, or just play around with them to see what they do. You can use build.nvidia.com to do that. We're going to talk a little bit about that in the actual presentation today as well. As well, if you're looking for other ways, you can look at us at our Hugging Face organization. That's huggingface.co/NVIDIA. This is where like all of our artifacts, that are related to our models live. So this includes data sets. We post blogs there now. Everything that you'll want to, actually use from the demonstration today is available on Hugging Face as well, which means that it's open. You can pull it down using whatever method you're used to. And we'll go to the next slide and talk about the last piece, which is we have a Discord, and you can ask loads of questions in there. It's active. We love engaging with the community here. Discord.gg/NVIDIA developer. So this is our developer Discord. You can join, and again, ask questions, talk to the community. It's a good rip roaring good time. Yeah, absolutely. I think with that, we'll get into the swing of it. Chintan, take us away. Tell us a little bit
Hey,
about what we're doing today.
Chris, I've got two questions.
Yeah,
The first one is, how do I get your energy?
coffee.
Well, I've got mine here. Anyway, let me share my screen and get started. Uh, all right, let me know if you. No, that's not what I want to share. Do you see? Um, do you see PowerPoint slide?
We do.
All right, awesome. All right, so guys, today we're going to talk about NVIDIA Nemotron. So I'm going to give you an overview of Nemotron, and then I'm going to talk about two different models, two different Nemotron models that we released in the recent past, including one that we released yesterday. And then Chris is going to give us a live demo, and he's going to essentially put this model into action. And let's see, what that looks like, what the performance looks like. So having said that, let's get started. So I'm going to forward. There you go. All right. So, what is Nemotron? So, Nemotron is a family of open reasoning models. And when we build these models, we think in terms of two major dimensions. The first one is that we want to build the models with the highest accuracy so that it works really well for agentic AI. And the second thing is for highest efficiency. And then once we build the models, we want to make sure that they're open. And so we open up the models, we open up the training data sets, we open up the techniques that we have used to build these models, and then we give it to you so that you can build on top of it, and it is available on Hugging Face. But we go a step further. We also package it up as NVIDIA NIM, which essentially means that you have this model in a container along with all the software that is required to run the model. And it is optimized for performance on NVIDIA GPUs, which means now you can take it and run it on a data center or on your workstation or in the cloud, right? So let me start with how we do this. We always start with an open frontier model. NVIDIA Nemotron is not an open frontier model. The family is not an open frontier model family. We build on top of the frontier model family, and we add our goodness to it to make it better, so that and then share it back with the community. So like I said, we start with the open frontier model. We prune the model to make it more efficient, and then we do knowledge distillation on it, because as we prune the model, it loses some accuracy, and then with knowledge distillation, we try to bring it back bring back the accuracy as much as possible. Once that's done, we apply different training techniques, and everything from continuous pre-training to supervised fine-tuning to to reinforcement learning, and that essentially uh, really moves the needle and helps us build this amazing model, and you'll see the performance and the accuracy in a bit. But at the end of the day, what really drives the accuracy is the training data set. And so what we do is we take frontier models like Quen, Llama, DeepSeek R1, and then we generate data from these models. We curate the data to minimize bias, and then we use that training data to train the models. Now, the type of data that is included in here ranges from math, scientific reasoning, coding, uh, function calling, um, instruction following, etc. Right? And then and we don't not only uh, train the models with this data set, but we also make it open, and it is all available on Hugging Face. The reason is because, like I said earlier, we want to be open. We want to be as transparent as possible, so that when you are using this model, you know how it was built. And then finally, this model, either you can download and run it from Hugging Face, or you can get it from NVIDIA AI Enterprise as a NIM, and then deploy it wherever you want. If you are a developer, you can still download the NIM as a developer. You don't get the enterprise grade support, but you get the rest of it. All right, so what have we done so far? We have taken a Llama 8B model, which scored 19 on artificial analysis intelligence index, and then we applied Nemotron methods to it, and we essentially pruned it. So now we have a Llama Nemotron Nano 4B, with a score of 34. So it went from 8B to down to 4B, and a score of 19 up to 34. We did the same thing with the Llama 405B. It started with a score of 29. We pruned it, and now you have a 253 billion parameter model with a score of 46. And then a couple of weeks ago, we launched Llama Nemotron Super 1.5, and that particular model, again, we started with a 70 billion parameter model, which had a score of 31, and then we pushed it up to 52. So now you have a smaller model with higher accuracy for agentic AI workloads. All right, so there are a few things I want to talk about. I'm not going to go into the all the details of the benchmarks, but essentially the benchmarks that Nemotron family focuses on is coding, math, uh, scientific reasoning, and then various agentic AI tasks. So in this particular case with Llama, one of the things that or with Nemotron rather, one of the things that I want to highlight is that we are committed to the development of this model family for the long term. And our approach is that we want to take the best frontier model that is available, and we build on top of that. So after the first version came out back in March, April timeframe, we started generating another set of data sets, another set of training data, so that we could retrain that V1 model to be a let's say 1.1 model, and look at how good, and improve the performance. And while we were in the middle of this process, DeepSeek R1 0528 came out, and we saw that the performance of that model was amazing. And so we halted all the work that we were doing, and essentially it was sunk cost, and we regenerated the data using that model for reasoning, and then retrained the V1 with V1.5, and the results were amazing. If you look at the second bar, which is Llama Nemotron Ultra V1, which I'd mentioned earlier, it's a 253 billion parameter model. When it came out, it was the best-in-class reasoning model, and now we have V1.5 Super, which is a 49 billion parameter model, so essentially one-fifth the size, and it beats the Ultra model in almost every single benchmark. Um, the 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 biggest value prop of this particular model is that it fits on a single H100. So it provides the best accuracy for a model that fits on a single H100. And when you talk about accuracy, accuracy is great, but obviously, it shouldn't take a ton of time to do it. So the efficiency is equally important, right? And so on the left side, what you see is a chart of throughput versus accuracy. And then when we compare the super model with a Qwen32B, we see a 1.6x higher throughput, which means that essentially you're lowering your total cost of ownership while improving the accuracy. Or another way to think about it is that you can make this particular model think faster and think deeper and think wider and get higher results for your agentic AI systems. Another thing that we announced last week was that Llama Nemotron Super, this 1.5 version, will be available in NVFP4. So the models that are available today on Hugging Face, as well as what you can try on build that Chris was talking about, they are BF16 and FP8, and then soon we are going to release the NVFP4 quantized model. On the right side, we are doing a comparison of running this particular model on an H100. And if you run it on H100, it doesn't have an NVFP FP4 option, so it only runs with an FP8. And so when we compare that to running that NVFP4 version on a B200, you see a 6x improvement in throughput. Again, that translates into higher efficiency and lower cost of ownership. All right. So the second model, like I mentioned earlier, we announced this, or actually we launched this yesterday. It's called NVIDIA Nemotron Nano 2. And this particular model is not based off, this is actually based off a Nemotron H model, which came out of NVIDIA's research team, and I think a couple of months ago. And so we are using that model as a base to build on and provide a more enterprise grade model, if you may, for the community or to the community. Now, this is a nano model. It delivers highest accuracy for agentic AI systems that are running at the edge. Now, when you think about agentic AI systems, what do they need? They need really good reasoning. Well, when you think about reasoning, it needs high compute, but compute is limited at the edge. And so we had to rethink on how do we make sure that agentic AI systems that are agentic or AI agents that are running at the edge can provide really good performance as well as accuracy, while fitting in a small compute form factor. And so the team decided to come up with well, they worked on a new architecture, which is basically a hybrid architecture of transformers and Mamba. And so now this particular model can take advantage of the best of both worlds. It can deliver the good accuracy that you would expect from a transformer model, but at the same time, because it uses much less, or rather a fairly capped memory, it can deliver high efficiency. And I'll get into a little bit of details in the next couple of slides. Another feature that we added for Nemotron Nano 2 is this thing called thinking budget. This is the first open reasoning model that has a thinking budget. So far, what you see is that you can either turn off reasoning or turn on reasoning. But with thinking budget, you can actually dial the reasoning depending on your application so that you can lower the cost of running your models and still get that expected accuracy you would want for your application. All right, so this is the accuracy across various agentic tasks, and so as you can see, when we compared the Nano to 9 billion parameter model to the Nano 8 billion parameter model that we released 3 or 4 months ago, as well as Qwen 3, it performs really well. But it's not just the 8 billion range. We have also compared this particular model to the 14 billion parameter model, the Qwen 3 14B, and according to artificial analysis, the 9B is currently beating the 14 billion parameter model as well. Um, In terms of training data set, this particular model was trained with with data that was generated from Quen 3 models, Quen 2.5 models, DeepSeek R1 models, and then NVIDIA curated it, and then we put it out on Hugging Face. Yesterday, we had put out additional data sets on Hugging Face, and this was basically focusing more on multilingual reasoning. So the Nano 2 not only supports English, but also supports reasoning in Spanish, Japanese, German, and there's one more language I'm missing out on right now. Anyway, so that's and then again, all the methods, the training data sets, the models, everything's available for you. So either if you wanted to start from scratch, obviously you can, or you can take another model and you can apply the data sets as well as the techniques to that model to build a similar model. We have seen in the recent past, where some of our enterprise partners have done it. ServiceNow, for example, they have taken a Mistral model, and then they took the Nemotron data set to apply it onto the Mistral model, and they put out that resulting model as on Hugging Face. They gave it back to the community. It's called April. So if you want to take a look at that, definitely give it a try. All right. So coming back to the hybrid architecture and what are the benefits of it? Because the Nano 29B is using the hybrid transformer architecture, it essentially is capping the amount of memory it requires, and it can run up to eight. It can run essentially 8 batch size. On the other hand, Quen 3 8B, because it's a transformer architecture, the amount of memory that it consumes keeps increasing as it generates more tokens, and so it is limited to a batch size of 1. And so because of the change in architecture, we are essentially able to deliver up to 6x higher throughput. And then I briefly talked about thinking budget earlier. So what this graph is showing is that you've got accuracy at a specific token budget for each of the 4 lines, and we just use 4 different benchmarks here. And so I'm going to focus on the one on the top, which is Math 500, the red curve. So as you can see, with a token budget of 1, you are somewhere in the 85 to 87% range. And as you increase the token budget, the accuracy actually plateaus, right? And so for that specific application, for that specific benchmark, it would totally make sense for us to say, okay, well, we are only going to limit or dial the thinking to 4,000 tokens, and then that way you save a lot on compute. And so depending on your application, obviously your mileage will vary, but you can get an idea of how you could significantly save compute, because as we know, with a reasoning on versus a reasoning off, it's like a 10x 10x use of compute, and this essentially helps you save significantly. Now, what you see up in the title is 60% saving. That's based off the graph here, and that is savings in terms of tokens. But when it comes to compute, the compute is quadrupled. So the compute cost is significantly higher than the saving, or the compute savings is significantly higher than just the token budget that you see here. All right, I am gonna hand it over to Chris so that he can walk us through a demo.
Yes, thank you, Chintan. Okay, so I'm gonna go ahead and share my screen now so you guys can see what we're looking at. So I'm gonna ask our production team to help me with that. There we go, perfect. Okay, we'll stretch it out a little bit so it fits nice. And the idea here is that we just want to do a small demonstration, show you guys what's up, where you can find things, how you can interact with this model. So first things first, this is our Hugging Face repository. We talked about this a little bit earlier. Chintan did a great job of kind of setting what we did, how we got here. The why of this series, right, is this model series is to enable people to understand both how to build these models potentially if that's what they're into. It's to help people understand what goes into making a model, as well as providing them with an agentic model that we can give certain guarantees to being us, right? So making sure that we're producing models that are open, that are permissively licensed. This is all really important. So that's why we're kind of doing this, and why I think it's important to people out there building. So this is the repo. You'll notice that there's actually 3 models. So we open source not just the final model, which we're going to talk about, which is this Nano 9B v2. We also open source how we got there. That includes our base models, which means that you can play with any step of the pipeline that Chintan was talking about. So on the actual model card, you'll find how to use it using transformers, a ton of great information. You can see this model card, it is beefy. It's got a lot of stuff going on, a lot of data, a lot of information, how to use it with transformers, how to use it with tier TLLM, how to use it with VLLM, how to make a custom VLLM server that it implements our thinking budget feature. All of this stuff is available to you. And you might say, like, well, what's this model good at? Why should I care about this particular model? So this is a breakdown of our intelligence index scores. And you'll notice that the model is, it's pretty good at things like humanities last exam. It's pretty good at, MLU Pro. This is other models that are, in the same range or one step up, right? In the case of 120B and 49B, you'll also see like, okay, it's fine at scientific reasoning, but the big highlight here for me is it's quite high up on this coding task, right? So very small, very fast model that's good at coding. You can imagine exactly where that's going to fit in to your stack. So this is kind of the idea of that, how the results shook out for Nano. If you want to read about any of the technical details of what we talked about, we have a resource page here it's everything. Again, pre-training data, post-training data, the technical report describing exactly how we got there, more info on Mamba if you want to get deep on that. Mamba, by the way, is how we got that really great inference that Chintan was talking to us about. So really, really incredible stuff. So how do we actually use the thing? So there's 2 paths that we're going to talk about. Number 1 is the actual build.nvidia.com endpoint. So this is the endpoint where you can run the model like you would expect any other provider. It's got a relatively generous rate limit, so there's not like a maximum requests per account. It's more like a rate limit, right? So you can't slam it because it is publicly available. But the idea is pretty simple. It's got a UI which will help you engage with different components of this model. So first of all, let's look at just a simple request from Amy 2025, which is this baseball team ice cream scoop question. You can see that the model reasons as you'd expect a reasoning model to do. And then, of course, we see the final answer, which gives us the correct response of 16. Okay. Now, there are a number of ways we can fiddle with the parameters here. We can go ahead and change anything that we're used to changing. So we can turn streaming on and off. We can change the total number of max tokens. We can change the temperature, though we recommend specific temperatures for reasoning on mode, as well as top P. So I wouldn't touch these if you want the optimal experience. You can set a frequency or presence penalty. But we also have these 2 parameters, right? So this is our min thinking tokens and max thinking tokens. And the idea is pretty straightforward. Our min thinking tokens is like, this is the minimum stop time. What that means is like a soft cap. So after we hit that min thinking tokens, we're going to try to stop the reasoning process. And what trying to stop the reasoning process means more technically is we're going to wait until the next new line character to stop thinking. So this means that, like, say we're in the middle of a big chonky paragraph of thought, right? We're going to let that thing go until we hit the new line or until we hit the hard cap, which is the max thinking tokens. This is the absolute maximum that you can get. Even if you're in the middle of a thought, you're going to get cut off once you hit that max thinking tokens. So this is how you use the model using the UI. You can also, of course, toggle reasoning on and off using the UI buttons here. But there's a limitation with this endpoint, right? And that is that it's only allowed up to 4096, right? For our max thinking tokens. We can't really set the the max tokens as high as we know they can go based on our model card, right? The model has a context of 128,000 tokens, and 8K is slightly short of that, let's say. So what you can do instead is you can actually use the notebook or the API to interact with this. So how do we set this up? Pretty straightforwardly, we just need to install OpenAI library. We're going to set our, and I'll zoom in a little bit here so you can see it better. We're going to set your NGC API key, which you can get by the following process, which is coming back here and then going to view code. If you're logged in, you'll be able to click the generate API key button and it'll generate you an API key. Once you have that, you just paste it into the box that appears when you run this cell. And then you're going to set up an OpenAI client, since all of our models are OpenAI API compatible, right? So you can use the integrate.api.nvidia.com/v1 endpoint, pass in your API key, and then you can use it like a normal model. Right now, the endpoint's being slammed to heck, so we're going to work on making sure that it's a little bit more stable. But the idea is this is just a chat.completions create command where you can pass in exactly what you're used to, which is the model, some messages. You'll notice that we have this /think message. Now, by default, the model is actually in thinking mode. So if you don't populate the system message or you don't populate it with the /think tag, it will reason. But just to be explicit in the notebook, we've added the /think, and then of course we can set the rest of our generation parameters, and then it'll stream a response to us. We also have the ability through the endpoint to add that thinking budget. So in this example, we've kind of like we haven't maxed things out, but we've shown an example with much larger numbers, right? And this idea is, again, we did explicitly add /think, though you don't need to, because again, thinking's on by default. We put in the baseball question. We set our max tokens to all the way max, and then we set our extra body parameters for min and max thinking tokens. So the extra body, min, and max thinking tokens is how you pass those through the API. So if you're using this through the API, this is how you would get this behavior. And we're basically saying, yeah, you're allowed to think for around 32K tokens. And then finally, of course, the model does work in reasoning off mode, which you can simply toggle by using /nothink. You can also emulate this behavior by setting very low thinking budgets, but this is going to be a cleaner way to do that. Unlike previous models where there was a guess involved, if the model was going to be reasoning or not reasoning based on just the training, we actually use chat templating here, which you can look at and read all about in the Hugging Face repo to enforce this rule, right? So when you put no think, the model won't think. Very, very crucial for when you're designing applications. If you're enjoying the model, not enjoying the model, have questions, feedback, anything else, the way to engage with us is through the model card in the community tab. You can make a post and you can tell us exactly how you're thinking. You can tell us what you think, what your experience has been with the model. You can tell us, anything that you think that might make your experience better with the chat template or anything like that. But if you want to engage with the process of building these models and kind of, participate in the community, this is the way that I'm going to recommend you do this. As Chintan mentioned, we dropped this model yesterday. So it's not the case that this is going to be there hasn't been a lot of time for people to contribute, but these forums eventually get quite large. But we just dropped this model, so we're very excited to get it into your guys' hands and show you a little bit how to use it. We will be sharing that notebook to you guys, so you can also follow that information and make sure you're getting popping with this model. So I'll share that to our team behind the scenes here, who can hopefully get it to you. And that's really it for our demo. I know that we want to move to some questions, so we're making sure you guys can get back to your days and maybe even get building with the model. Okay, so let's do some questions then. I see that we have some starred for us. If we want to pop those onto the screen, we can get answering them. Is it, as it is not a frontier model, can it be used to deploy commercial solutions? So this is a great question. Can it be deployed with a commercial solution? Answer, absolutely, yes. Chin, go ahead.
Yeah. I agree, and this is what it is for, right? Like it has a very permissive license, so use it for your application. One of the biggest concerns is how the training data is generated, and then essentially what we have done is we have taken frontier models to generate the data, and then we have put it out there on Hugging Face so that people can use it. So short answer is yes, use it for your commercial deployments.
And I've got on the screen here the NVIDIA Open Model License Agreement, which is a modified Apache 2 license. There are a few additional conditions related to, you can read the license and get the full idea. But this is an extraordinarily permissive license, and we're happy to say that this is a NVIDIA Nemotron model, which means it has our NVIDIA license right out of the gate. Awesome. We'll go to the next question. As GPT OSS is MOE, can you also use Megatron LM to tune it in place of Llama? Specific versions of models and their training, I'm going to defer to our Megatron team, but I'll make sure that I get an answer to this question. I'll follow up with Paul. The idea is that some of these models that come out have unique architectures, or they have unique components in their architecture, and so we want to make sure it goes through the whole testing suite before we say for sure you can train it. I'll make sure that process is either being done, or what the timeline is, and I'll let Paul know. We'll go to the next question. What metrics are used for the evaluation? Great question. There's a number of metrics that we use internally, but the ones that we talk about externally, and you can find all those on the model card, by the way. So if you want to know exactly what we measured this thing for, you can look at the model card. But the ones that were third-party verified or independently verified are these the intelligence evaluation by our friends at Artificial Analysis. You can see all of those here. So we have MLU Pro, GPQA Diamond, Humanities Last Exam, Live Code Bench, SciCode, IF Bench, which is a new one, AMI 2025, and AALCR, which is a long context evaluation. So it went through the whole kind of barrage of intelligence evaluations to get to that final score that Chintan was telling us about, which we see here. Excellent question, though. Excellent question. We'll go to the next one. When you publish FP8 weights for Nemotron 9B, Chintan, we got anything here?
Yeah, over the next few days, it is in the works. We've already seen the model, so it should be any time now.
Coming soon. Not a bad answer. Okay, we'll go to Raj's question next. In setting optimal token budget for high accuracy, any better approaches other than test and trial? So, listen. Hyperparameters, you're always going to get a little bit of trial and error involved. However, I'm just going to, if you allow me to scroll a little bit, I'm just going to show you guys this. You'll notice that there's actually kind of this spread on the budget for different domains, right? So we have like math is here, Amy is getting there, right? We've got our science budgeting around here, LCBs around here. The idea is I would take this as like a starting place, as like a template to use for your reasoning budgets. Depending on what kind of performance you want by domain. Other than that, though, there is going to be trial and error, but I would use this as a starting template. We've tried to do a little bit of the work for you guys so that you have a place to start. But of course, as each task is independent, you're going to find yourself needing to do a little bit of science to figure out exactly what's right. But this should be a good jumping off point. Chintan, anything you'd like to add there?
No, I mean, we totally expect developers to do experimentation to, wish there was a better approach than test and trial, but not at this point.
And not to shout it out too much again, but of course, Raj, if you find yourself experimenting and you find a thinking budget that works really well for your task, a great place to tell people about it would be this community forum. Let people know how your experiments went, what you've learned, some wisdom that you've garnered, so you can share that back to the community. We'll move to the next question. How much computational power do you guys use for training the model? That's an excellent question. And what we're going to do is just scroll on down the model card, and you can see exactly how much computational power we used and on what phase we used it on. Check that out. So this is not a question that is ambiguous. We share, again, this is very open source. So we're very open about what's happening here. You can literally read exactly how much power we used on which phase, both in terms of energy and flops. I hope that answers your model or your question rather exactly. You know, it's not too bad, really, to be honest with you. Okay, if we've got time, we can move on to questions. Just let us know. Are there plans for a GGUF version as well? I'm sure that the community is hard at work on this. This is a novel architecture, right? So it's a hybrid architecture between Transformer and Mamba. So it's probably going to take peeps a little longer than usual to get GGUFs out. But Local Llama yesterday was already starting to talk about it. I'm sure that the community wizards out there are hard at work at this GGUF conversion. Though again, it's a little bit harder than usual, so it might take longer than usual because it is new architecture. Yes. Alrighty. Should there be any concerns regarding transferring previously trained data for any upgrades between systems or those who may transfer different models to your model? Chinny, can you help me parse in this question?
I'm trying to read the second part. And so should there be any concerns regarding transferring previously trained data for any upgrades between systems?
My gut's telling me no. Where are you at, Chinton?
Yeah, I don't think. I mean, I think if I read this question correctly, it is essentially saying that I have training data coming from a different model, and then feeding it up to this model to customize the newer model, whatever that may be, and don't see a concern with there, or those who may transfer different models to your model.
If this is a question about like, does the license allow you to modify the weights or use synthetic data from this model to train other models, then the answer is definitely yes. You can read the license to get the exact details, but the answer is yes. I think that's what I'm erring towards. Trevin, if you want to follow up with us, or me on LinkedIn, Chris Alexiak, I'd be happy to clarify and answer the question. Let's go to our last question of the day. Thank you guys so much for all of these awesome questions. They've been really great so far. Smaller models often are specialized for specific tasks. Is this model also optimized for specific aspects? If yes, which ones? Another great question. And the answer is, this is a good indication. The intelligence index is a good indication of where we really focused our efforts for this model and what we really think it's going to smash out of the water. It is designed to be general, right? It's designed to run agent applications, which means that it should take information well and do things like RAG very well. Its general knowledge is not going to blow you out of the water. It's a 9B model, right? But it is meant to be specifically for building agentic applications. Chin, do you think that's a good summary? Anything?
Yeah, and I know the questions are focused on small models, but I wanna up level it to the Nemotron family, right? And essentially the models that we're building for the Nemotron family are for the next gen applications, which is really agentic AI. And when it comes to agentic AI, the agents want to run efficiently. They need reasoning. They need to understand different, instruction following tasks and function calling and so on. And so the Nemotron family, when we build our models, when we start building our models, these are the benchmarks that we look at, and we have a certain target that we focus on.
And there you go. And there you go, guys. That's it from us today. Really appreciate all of you coming out. Loved all of the comments in the chat. Great questions. Really appreciate it. So thank you for me. I've been Chris.
Chintan Patel.
There you go. And
thank you for joining, guys.
Have an awesome day. Have an awesome day, guys.
Thank you. Bye.